All right, fourth graders. So I know we've been practicing how to do this long division using the algorithm and using our wonderful little note card. So what I'm going to do is I'm going to show you the algorithm way, but I'm also going to show you how that relates to the box method. And the box method is something we're going to be kind of practicing more on Friday, but I want you to see it so that you can practice it on Friday. So for the basic algorithm, so we're going to, just so you know, I'm looking at page 6. That would probably be useful information. On page 6, we're going to look at the first row, which is row A. And when I'm looking at this, if I use my note card and I do the basic algorithm, I'm going to shrink my problem down. I know what I'm thinking is 3 times something. That's really how we think about division. Our divisor is 3. We're thinking 3 divided into, we're going to shrink it down to just an 8. 3 divided into 8. And so I ask myself, 3 times what gets me as close to 8 without going over? So I know it's not a very big number, so, well, 3, 6, 9. 9's too big, so then I know it must be a 2. That's my division. And I said 3 times 2 is where I got my 6. Now 6 was as close to 8 as I could get. So again, thinking of these steps, 3 divided into 8 is 2, because 2 times 3 is 6. So that I can subtract and find the difference, since I couldn't get all the way to 8. So I subtract, I get a 2. I always compare and make sure it's less than my divisor. It has to be less, which it is. So now I can see if there's a number to bring down, which, amazingly there is. So I want to point out again that that 6 is really in the tens place. It's almost like a 60, just like that 2 is really in the tens place. And if you think about 87, take away 60, you could see it would be 27. So now, after I bring down, I must repeat. So now I've got a new number. It's 27. So then I repeat, 3 divided into 27. Well, that's a much bigger number, so I know it's going to be a lot bigger than 2. So then I start thinking about the numbers that I know. I can skip count. I can do my 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27. Oh yeah, well 30's too big. 27, oh yeah, that was 9. So I said the closest I could get to 27 was 3 times 9. So remembering that 9 is what goes on top, because 9 times 3 is 27. I couldn't get any closer. Boop. So then I can subtract. I get 0. I compare. It's less than my divisor, and there's nothing left to bring down. So my answer was 29. Remainder, 0. So I don't even have to have that remainder if it's a 0. So what I want to show you now is how we relate this to the box method. And some of you might prefer to try it this way. So if you like what I'm about to show you, you can actually do this on a piece of scratch paper. You can do it on a piece of binder paper and just turn it in with this, or at least, whether you turn it in or not, at least keep it so that when we correct and go over this, that you'll be able to see the work you've done and compare it and be able to decide whether you've gotten the right answer, or is this the best way for you to do it. So the box method looks very similar. We have our 3 on the outside, and we have our 8 and our 7 on the inside. Now I like to leave a little room in front because we might be doing some unbundling, which is like subtraction, which we've done up here. So first thing I ask myself is 3 divided into 8. Same question. How close to 8 can I get? 3 times what? Again, we know the answer is 2. Therefore, 2 times 3 is 6. So I'm going to follow those same steps. 6 was as close to 8 as I could get. I'm going to subtract. I get a 2. All right, I compare. It's less than my divisor. Now, this is where some of the kids, the bringing down can be confusing. So a lot of kids like to do what I call unbundling. So instead of being a 2 in the tens, it's going to become 27 ones, which it is still 27 ones there. It just looks a little different. In this case, we did our division. 3 divided into 8 is 2, because 2 times 3 is 6, allowing me to subtract. I compared. My 2 was less than my divisor. Instead of bring down, it's bring over. And that's another way you think about bring over. Maybe your arrow goes that way instead if you like the box method. And I have to repeat. So 3 divided into 27, well, we've already established that that was 9, because 9 times 3 is 27. Can't get any closer to 27 than 27, so when I subtract, I've got a 0. So there's no more unbundling because there's no place to unbundle. If I had something left in my last box, it would become a remainder. But I don't, so I have no remainder. So what we're going to do now is we're going to practice another problem, and I'm going to show you how it relates again to the box method. This time I'm going to go a little faster, so I want you to work it with me. Okay? So shrinking it down. 3 divided into 4. So I'm again thinking 3 times what gets me as close to 4 without, well, that's easy. There's only 1. If I did 2 3s, that's 6, and that's too many. So noticing my 1 goes there because 1 times 3 is 3, and 3 was as close as I could get without going over. Then I subtract. 4 take away 3 is 1. I compare. It is less than my divisor. So I see, yep, I have a number to bring down. It's a 5. So then I say, oh, new problem. I've got to repeat. 3 divided into my new number, which is 15. And you can see where my 15 came from. This 3 is in the tens place. So it's like a 30. So when I subtract 45 from 30, that's where my 15 comes in. But instead of having to remember all those zeros and hold on to it, we just use the bring down method. So this is for the algorithm. Again, I brought down, so I'm repeating. 3 divided into 15. I know my 3s. 3, 6, 9, 12, 15. Oh, that's exact. It's a 5 because 5 times 3 is 15. Now I'm going to subtract. Oh, that's an easy one. And I compare. It's definitely less. There's nothing to bring down. That makes that my remainder, which means I don't have a remainder. 0 means nothing. All right? So again, some kids, like when it's only a couple digits like this, the bring down's not so bad. When we get into where we're in the hundreds and thousands, it's a little harder. A lot of kids get stuck in all this bring down, which is why you might consider the box method, which is why I want to show it to you. So again, I know that I'm only going to have 2 places because it's just a tens and a ones. So when I draw my box, I need to just make sure I've got my 10s and my 1s, since that's what I'm dealing with. My 3 goes on the outside. My 4 and my 5 stay on the inside. And I again ask myself, using the exact same steps, and I can even shrink it down. 3 divided into 4 is 1 because 1 times 3 is 3. Take those 3 out, leaving 1, which I know I would compare, which is less than my divisor. So now instead of bring down, I'm going to bring over. So I'm going to unbundle it, bringing that up here. So then I have a 15. 3 divided into 15 is 5. Because 5 times 3 is 15, can't get any closer, I have no remainder. And I know it's less when I compare. So again, you can see that this box method is basically the exact same thing as the algorithm. I've just found that some students prefer this unbundling because it's similar to what you've learned with addition and subtraction. So it's easier for them to keep track when we get to larger numbers. So I wanted to make sure that you had a chance to see a couple examples and see that you are allowed to use this box method with these pages. If you prefer to do it that way, that's okay. There's one other way that we're going to be working on, and that is if you really don't know your math facts well, there's another strategy called partial quotient. And it is just like fast subtraction, and that's really what division is. You're taking groups away, all right? If I had 45 pencils and 3 groups, I'm taking away a certain amount of pencils from each group till I use them all. All right, so I wanted you to have a chance again to see that box method. I'm not going to do this problem the algorithm way. I want you to give that a shot, but I'll show you how it relates to the box method. And you might even be able to use this box to help you solve it in the algorithm. So, one last thing. If you choose to use this box method, you do not have to necessarily fill all this in unless you really want to learn. If you really want to learn this algorithm way, and this makes more sense to you, if you do this first, you can see how it relates to these problems. And you're welcome to try to fill in these problems using your box method. But If that's too hard for you, if you're like, nope, I just want to do the box method, then again, do not get rid of this paper until we've corrected, because I'm going to want to see your work. All right, so coming back to this last problem again, or not last, but the last one we're going to do together on the video. If I have 3 divided into 78, I'm going to ask myself, as I have every time, it's 3 times what gets me as close to 7, in this case, without going over. So I say 3, 6, oh, 9's too big. Therefore, 6 was as close as I could get, but how did I get that 6? 3 times 2. So that's where that 2 goes on top. 3 divided into 7 is 2. Because 2 times 3 is 6, which was as close as I could get. That's going to go under my 7 so I can see what do I have left. Well, I have 1 left. It's my subtraction. I compare, it's definitely less than my divisor, so now I bring over. Boop. So now I'm going to take that 110, bring it over here to make it 18 ones. Now I can just treat it as 3 divided into 18. 3, 6, 9, 12, 15, 18. Wait, I can't get any closer to 18 than 18. Well, I said that 3 times 6 was what I used. So my 6 goes here because 6 times 3 was 18. I couldn't get any closer. I have nothing after I subtract. Clearly, if I compare, I know it's less. And since there's nothing there and nothing to bring or unbundle, I know I don't have a remainder. And 26 would be my answer. So I want you to see how this relates so that you can kind of choose the strategies you want to use that help you to learn this. All right, you guys.